Hello and thank you for watching. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video I will do a demonstration how to configure OSPF version 2 advanced features. This is lab 5158, configuring OSPF version 2 advanced features. Earlier on I just did 5119. Please have a look at that if you haven't seen. This is advanced features. This is the topology. We have router 1, 2 and 3, and we have PCA and PCC to use. I've got virtual machines, PCA, and let me start PCC as well. All this I'm doing it from PCB. Now those are 3x3 virtual machines, but those router 1, 2 and 3 are actually a physical router, which I have a connection to them through an access server. So if I do show session, 1 is router 1, session 2 is router 2, and session 3 is router 3. Right, I did reload, so I erased everything. So if I go to router 1, I have nothing. Would you like to enter initial configuration dialog? Means there's no startup configuration. So if I go to router 2, same thing, say no, I don't want to enter. And I'll do the router 3 as well, say no on the wizard. Okay, so what I'm going to do now is I'm going to open a notepad. This is notepad 5199, so I'll close it. I feel bad because it's exactly the same as the startup configuration is same as the 5119. Anyway, I'll do that from the beginning because I've seen some students that they want to see the whole thing from the start. So I'll open the notepad now and put it here. Now the configuration is going to ask us to do the startup configuration, yeah, for all of them. So first I tap enable, then config T for all of them. Then it says this step, disable the DNS lookup. Step 3, section A, disable DNS lookup. So no IP domain lookup. Step 3, section B, configure device name as shown in the topology. So we have a host name, it's going to be R1. Assign class as a privilege exec mode. So enable secret class. Assign Cisco for console and VTY line password. So line console 0, password Cisco, login. And then for VTY, so line VTY 0 to 4, password Cisco, login. Then it says encrypt all clear text passwords. So we have to encrypt the clear text password. That command is service password-encryption. Then configure a message of the day banner. So banner MOTD. And we start with the character, so we want to say unauthorized users or access is prohibited. Alright. Configure login synchronous in the console line, so I have to go to console line, says login sync, and configure an IP address as listed in the table. Alright, so let me just take this host name, put it down here, because I'm going to change it for all of them, yeah? Alright, so I highlight all this, right click, copy, go to router 1, so Control Shift 6X to go to access server, show session, then I press 1, now I'm router 1. So just right click and paste in there. Make sure that we don't have any errors, everything seems okay, great. So I'll change the name here to router 2, copy, go to router 2 and paste it. And then I'll change it to router 3, so R3, copy all that stuff and go to router 3 and paste it there. So right click, just right click and press OK. Okay. Now configure an IP address. The IP address is listed on the table. So if I go to the table, these are my IP addresses. I need to configure them. So Then we go to Notepad. Right, I'll make a small separation here. This is R1, so I need to configure these IP addresses. These ones here. Sorry. Okay, so interface. I don't have gigabits, I have fast Ethernet. So fast Ethernet 00, given IP address 192.168.1.1. No shutdown. Then I'll go to the serial interface, S000, IP address 192.168.12.1, 252. This is a DCE, so clock rate 64,000. I think it's 128,000. 128000. That was the last lab. Interface phase S010, and then given IP address. IP address 192.168.13.1. Here we just need to do no shutdown. Here, no shutdown as well. Sorry. Down. Alright, so we got our three interfaces. FA00, 192.168.1.1. That one there. 192.168.12.1 is this one here. 192.168.13.1 is this one here. Okay, that's for router 1. Router 2, I'll just copy the router 1's config and I'll paste it for router 2. Change this to router 2. Router 2, it doesn't have interface FA00, but it has a loopback interface. Yeah, so I need to change this. Say loop back 0, and the IP address is different. It's 209.165.200.225, and the subnet mask is /30. Don't need to do no shutdown on the loopback. S00, 192.168.12.2, so change that to 2. Get rid of the clock rate because it doesn't have. So I can cut this because I'm going to paste it on the other interface. S001, or S10 for me, 192.168.23.1. This one does have a clock rate, so I'm going to put it here. Alright. Now I'm going to copy the stuff from router 1 and put it for router 3. It's very similar. Just change the name. So G00 3.1, S000 13.2, so 13.2. This is the DCE, so that's it, I'll leave that. S010 for me is 23, 192.168.23.2. Alright, that's the configuration of IP addresses. So copy all that, right click, copy, go to router 1 and paste it. Copy router 2's config, go to router 2. For you guys who didn't watch the video, if I'm in router 2, for example, now I need to go to router 3. First I need to go to access server. So to do that I need to type control plus shift plus 6, control shift 6, and then X. Release that and then put X. So release and then X. So release the one keyboard together, control shift 6, and then release, then the X, then you are in access server, and then you put the number. Either if I want to access router 1, I put 1, router 2, 2, and router 3, 3. Okay, so I need to do the router 3 stuff now. Copy. I got to router 3, control shift 6, X, the router 3, and I'll paste it there. Excellent. Okay. The IP addresses of the PC 192.168.1.3 is exactly the same. This PCs. So if I go to PCA and from the other config. So IP config, I don't need to change here anything. 192.168.1.3 and PCC, the same one. 3.3, 3.1 is the gateway. So 3.3 is PCC and 3.1 gateway. Okay, excellent. The configuration is there. Last thing we need to do is to save the configuration. So copy the running config to the startup config. So for all of the devices, I'm going to say copy, small letters, copy running config to startup config. That's it. Copy that. Go to all the devices, so end, and then paste it there. Go to router 2 and paste it there. And then I'll go to router 1 as well, and I'll paste it there. Right, router 1 should be able to ping router 2, the neighbors, yeah, and router 3. So if I say show IP interface brief, so I should be able to ping 192.168.12.2. Should be able to ping this address. So ping 192.168.12.2 and success. And my directly connected neighbor is this one as well. So ping 13.2. Yep, works. If I go to router 2 and I'm just gonna ping his neighbor, so ping 192.168.23.2. Excellent. PCs, can they ping the gateway? 1.1, that's a gateway. Yep. PCA can ping the gateway, and PCC, can PCC ping the gateway? Yeah. So the network is fine, it's working fine. I can't ping from PCA to PCC because there's no routing involved yet. Configure PCs, we've done that. Test connectivity, we've done that. Configure and verify OSPF routing. So we configure OSPF version 2 on all routers. So configure the router ID to be router 111 and so on. Okay. So if I go back now, router 1, for example, is going to advertise these 3 networks. Right, so I have to go enable routing. So this is for router 1. Make some space. Router OSPF 1. Router ID, manually we set him. Just router ID, sorry, not subnet mask. Then we have to advertise gigabit or local LAN. Network 192.168.1.0 000.255. It's the wildcard mask. Area 0. And then we advertise in the second network, so the serial network. So network 192.168.12.0 0003, the wildcard mask 0. The last lab I explained how to get the wildcard mask for the network. And then 13 as well. Right. Router 2 is not going to advertise this network, but they will advertise those 2 networks. It's going to enable them. So I've got to copy all that. So this is for router 2. Router OSPF 1, ID 2.2.2.2. Network, it doesn't have this network, but it's got 12.0, which is that one, and 23.0. So 23.0. Okay, and we're gonna do same for router 3. So we go to router 3. Router OSPF 1, network 3.3.3.3. Oh, sorry, router ID. Network 192.168.3.0, so 3.0. 13.2, so 13 is for there, and then 23 as well. Yeah, so this one I can change it to 23. Alright, that's how we enable routing. this interface G00 is going to be the passive interface. So let's do that as well. So we do a default passive interface, default, and then no passive interface S000, and no passive interface S00010. Right, we do these for the other two routers as well. Okay, so copy all this stuff, set it to router 1, config T. Right, no errors, great. Copy the router 2 stuff, go to router 2 and paste it, and then copy the stuff for router 3 and paste them there. Okay, now if I go to router 1, I should see two neighbors, show IP, OSPF neighbor. Yep, I got router 2 as a neighbor and router 3 as a neighbor. That has got full adjacency and it's point to point. Show IP OSPF interface brief. I got those are the interfaces for the OSPF, two of them point to point and one of them multicast, multi-access I should say. Show IP protocols. I can see that we have OSPF as a protocol that we run in OSPF version 1. We are routing for these networks, and passive interface FA00 and 01 we put it because it's default passive interface. Yeah? Okay, the distance, administrative distance is 110. Alright. So now when we do show IP route, for example, show IP route OSPF, I just want to see OSPF routes. You can see that I learned, sorry, okay, let's run it again. I learned 192.168.3.0, that's a local area network of router 3, and I learned the connection between router 2 and 3, the serial connection, and I can load balance for that network, right, from router 1 to this network here, this serial network. I can send them, either I can send router 2 or towards router 3. See, that's towards router 2 and that one is towards router 3. Okay, so now my PC should be able to ping each other. So if I go to PC, you could ping the gateway, but this PCC, if I say IP config, it's got the address 192.168.3.3. So if I ping that address, ping 192.168.3.3, and I got a reply. If you don't, check the firewall as well, because the firewall sometimes will block the pings. That's the default setting on Windows computers. Right, configure OSPF network on all the routers, verify OSPF setting, which we did, show IP OSPF neighbor, we did, show IP route OSPF, which we did, test end-to-end connectivity, which we did, PCC, ping PCC from PCA, verify end-to-end connectivity, which we did. The ping should be successful. If they are not, we troubleshoot. Like I said, you might need to disable the firewall for that. The metrics, in part 3 we will change the OSPF metric using the bandwidth command, auto cost reference bandwidth. Remember the metrics, like if we looked at it, for example, that's a default, yeah, gigabit, 10 gig and fast ethernet all equals to 1, so that's a reference bandwidth 100 million. So we can change it to 1 billion or 10 billion, so the reference bandwidth is not going to be the same for all of them. Okay, so we can do it with auto cost reference or by just saying the bandwidth. So by default, right, if I say show show IP interface S000, so if I do show interface S000, so you can see that by default the bandwidth is 1544 kilobits per second. Now maybe you don't have that, that's the default bandwidth. So if I say show IP OSPF interface brief, you can see the bandwidth, the cost is 64. But if I change the bandwidth, so I go to that interface interface S000, say bandwidth 128. The cost will change. Show IP OSPF interface bandwidth. See, that cost now has changed from 64, it's gone to 781. Okay, so if you change it with the auto cost reference bandwidth, then it's going to change for all of them. So we can go to config t router OSPF 1 and say auto cost reference bandwidth 1000. This command we have to enable it on all the routers. So let me just copy and put it in my notepad, because this is going to go for all routers. So router OSPF 1 auto cost reference bandwidth. What you're doing, you are just changing. Let me just open this. You are changing this 100 million to 1 billion. Okay, so if I go to, you have done there. So if I go to router 2 and do the same, and to router 3. So we have consistent auto cost reference bandwidth. Or we can choose individual interface. We can tell what is the cost rather than letting it to. Okay, so if I go to router 1, for example, let me go to router 1 and show IP OSPF, OSPF interface brief. You can see the bandwidth has been changed, but here to 647 because we left it to default 1544 megabits per second as an interface of serial. You can change this cost yourself. You don't have to do like let the OSPF calculator. So you can go interface S0 what is it, 10 for example, and say IP OSPF cost 1600. Okay, then do show IP OSPF interface brief. You can see we can tell exactly what is the bandwidth instead of just leaving the calculation. Now, Cisco configure and propagate a static default route. For example, you see that router 2 has a default route towards the internet or towards that loopback. So what we're going to do, we're going to configure a static route that's going to point towards the internet, and then we're going to generate that. Configure a default route using the loopback interface configured on part 1 to simulate the connection to ISP. So okay, let's do this. This config is going to be on router 2. So what we say here, IP route default route quad zeros, with quad zeros for subnet mask. What we're gonna do, where are we gonna send it? We can either tell the next hop IP address, which we don't have in this case. We only have a loopback. So loopback, what did I say? Loopback 0 or loopback 1? Can't remember now. Loopback 0. That one there. Okay. So static route towards loopback 0. Copy. Go to router 2 and paste that. Okay, that's like a reminder. Default route without gateway, if no point-to-point interface, may impact the performance. Like a small warning there. Show IP route. When we see that we have a gateway of last resort, which means that the router will look at all the routing table, try to match more specific route. If it doesn't match, then it's going to revert to this default static route. So gateway of last resort for all these networks, and it's going toward loopback 0. If I go to router 1, router 1 still doesn't have any show IP route, doesn't have a default route. So gateway of last resort is not set. Because we have a router 2 has a gateway to last resort, we have to create that. So we need to go to the router OSPF 1, say default information originate. Okay, copy that to router 2. Okay, now once we've done that, because we have that static root configured, this will work. If we didn't have that static root configured, that will not work, and you would have to put another command, which is always, right? That will give you, like, it will originate a default static root even if you didn't have a static root. Obviously we can change the metric as well, metric type, because it's gonna tell them, redistribute them as a metric type too. Okay, this is more like CCNP static, but for now, because we have an IP root, a static root, and we can propagate this default root. Okay, so if I go to router 1 now and router 3 and do show IP root, see now I should have, yes, I have a default root that says gateway to last resort for any network. I'm going to send it towards router 2, and I learned an OSPF external type 2, a default root. I can do the same for router 3, show IP root, and we can see that we have the same thing. We have a gateway of last resort. Okay, to verify it, yeah, we did that. Verify end-to-end ping connectivity is assumed by pinging from PCA to the ISP interface, that interface. Okay, so we need to go to the PCA and try and ping this interface, 209.165.200.225. So let's try it. So ping 209, I can't remember, 209.165.200, 165.200 dot, what is it, 225. Okay, 225. Yep, we have a reply. So that means that we have a reply towards this network. Any networks on the internet now, we would be able to ping it. But even though the router 1 or router 3 doesn't have 209 anywhere here, anything, it doesn't have 209.165 anything on the routing table, so it didn't match more specifically, but it does match the default route. So I can do it from PCC as well. So if I go ping 209, still can't remember, 165.200, 165.200, 225. Yeah, I can ping it as well. Okay, now we're going to configure OSPF authentication. We said that the OSPF are the routers are target for denial of service or anything. OSPF authentication can be set at the link layer or the area level. There are 3 types of authentication in OSPF. First, no authentication at all. Then we can have a clear text, or we can have a message that is just 5. Okay, so set up a MD5 OSPF authentication on a single link. So issue the debug IP OSPF adjacency command on router 2 to view OSPF adjacency messages. So we go to router 2 and say debug IP OSPF ADJ. That's it, that's the command. It's not actually adjacency, ADJ. And then say assign an MD5 for OSPF authentication on router 1 interface. What I'm thinking here is I'm actually thinking maybe I should telnet from our PCA so we can see the debug messages. Yeah, because otherwise we're not going to see it. So I got the PCA, and yeah, you can do PuTTY telnet to router 1, 168.1.1. Yep. Enable plus. Right. So here we have enabled our debug. There's nothing happening. But once we enable OSPF authentication on router 1, on the interface towards router 2, this one is going to go down. Yeah. So let's go. Say config t interface S000 IP OSPF authentication. We're going to use message digest. message digest. That it? No, message IP OSPF, no authentication first, just message digest. Well, you can use this first, it doesn't matter the order actually, and you can say then this OSPF message digest key, then put the key. Okay, IP OSPF message digest key, and then key ID 1 for example. This has to match the ID. MD5 Cisco. Right, I don't know if they want the Cisco or something else, but just an MD5, it doesn't matter what. But that's the password, that's actually the password. As you can see here now, we have some errors in our debugs. It's saying this one received a packet from router 1, mismatched authentication type. Input packet, we got to require a lot. Input packet specify type 2 as MD5, we use type 0, which is a clear text. Clear text to type 2. Type 1 obviously is going to be plain text. Show IP OSPF interface S00. Hold on. Issue UAll command, which is shortest version for undebug all on R2. Configure OSPF authentication R2 interface S00. Use the same MD5 password we configured. Okay, so I don't know. Should I do UAll or should I just keep it? Yeah, let's just keep it. See what happens. S000 3 zeros there, and say IP OSPF message digest key 1 MD5 and then Cisco capital letters. IP OSPF authentication message digest. So now we have got both of them. Both of them are using message digest, MD5 message digest. So as you can see here, now I can stop it. Do UAll. Do on debug all. Send with youngest key 1. Receive the database from 1111. Two-way communication, we went to two-way. And neighbor 1 prepare database exchange. Send database we are sending. Again, we check changing the keys, making sure that we're still there. First DBD, and we are not slave, so we are the master, because they have a lower router ID. Receive DBD from 101. Neighbor negotiation done. We are the master. Neighbor 111 summary list build. Send database. Receive the database. Exchange is done. Synchronized with, we all synchronized together, same as with router 1, and state is full. So now between router 1 and router 2 there's authentication. You can say we can verify it, so say show IP OSPF interface S000. You can see the message digest authentication is enabled and we're using key 1. Set up authentication in the area, so issue the area 0, so we can enable authentication just for the interface, or we can enable for the whole area. So if I go to router 1 and say router OSPF 1, I can't do that, config T, router OSPF 1 area 0 authentication message digest. So it means the whole area now is going to be using message digest authentication. Right, I haven't typed any of these commands in here. What do we do? I'm just going to type it because then I'm going to share this command. Here we typed, well, something similar to that. Control C, because this I typed Cisco. Then I went to this interface. This was a router 1, and then message digest IP OSPF. Okay, this was for router 1, and then same config we did it for router 2 as well. Now router 1 and router 2, it's got configuration, but we can enable for the whole area. So we went there and the router 1 and we did for the whole area. So we did area 0 authentication. So we went router OSPF1 message digest, and then this is going to cause a problem here, because you see router 3 is not authentication. We are authenticating the whole area, and we have to tell what is the key towards router 3. So IP OSPF, that's the key. And we have to do the same thing for router 3 as well, because router 3 will have to type the key as well for all the key. So we can do this. This is telling us that we can do it per interface basis. So router 1 and router 2, and that's it. Just router 1 and 2. And this is telling us that we have to do it. We can do it for the whole area. But if you do it for the whole area, then every interface in that area has to be authenticated with message digest 5. So here we go. And for router 3 as well. Okay, IP OSPF, message digest, and then the keys as well. So each interface is going to have the same key. So we don't have to type this, because that's already been typed in the area. Right. So both of serials, they're going to have the same. Here, we don't need to type. Like this. Okay, let me just get rid of these. We enable an OSPF authentication in the whole area, and then each interface will have its own key. Right? Both sides, they have to share the same key. So for example, like this. Okay, we can put this config for the whole every router. Right. And go to router 2. And I go to router 3. Class config T, and then paste it. Now it's important that this is not enough. If you just put like this, that's not enough. You can't just have this but not the key. So you have to have the key as well, right? Okay, now if everything worked, we should have our two neighbors again working. So if I go to router 3, do show IP OSPF neighbor, yep, we have our neighbors. If, for example, if you wanted to have a clear text authentication, right? If I put enter here now, if I enter it, then it will be type 1 or plain text. Message digest, we type 2, or null, no authentication. So there's 3 types. Either press enter, you're using plain text, type 1, message digest, type 2, or null, type 0. Okay. Let's use that. Let's just show that. So IP OSPF authentication, and that's it, enter. And if I go back to router 1, am I with the router 1? What interface did I do this? Interface S00. Yeah, that's router 1. So if I do router 1 debug and debug IP OSPF adjacency, and see if there's a problem, because router 3 is telling plain text type 1, and router 1 is using type 2. So show IP OSPF neighbor, still have the neighbors. Okay, show IP interface brief. Right, you can see that it says we have a packet problem here, because it's like input, they come with packet type 1, they have a plain text authentication, and we have authentication type 2, which is message digest. Okay, this has been Astrid Krasniqi demonstrating to you how to configure the lab 5158, configuring advanced OSPF settings. Thank you very much for watching this video, and please don't forget to subscribe. Bye bye.